How you going, guys? Before I start, Kramer, this is for you. I just want to show that my division of polynomials is the correct way. And I'm going to do an example from just a 2-unit paper by using division of polynomials. So the question was show that 1 minus x plus x squared minus 1 over 1 plus x equals x cubed over 1 plus x for x does not equal negative 1. This was part of a question 10 from 2009. It was just an algebra part. It had something to do with the question, but later on. But anyway, we're just taking out this part. So the 2-unit way to do it is you take the left hand side, you'd restate it, and then you put everything over 1 plus x, and in brackets on the top value is 1 plus x, and you multiply it out, blah blah blah, you'd end up getting x cubed over 1 plus x. That's a way easier way than what I'm going to do now. This is just to prove to Kramer that I can do it. So Kramer, this is for you. That's what I'm talking about. So we take the right hand side, equals x cubed over 1 plus x. Now we're going to divide this polynomial, this one here, x cubed on 1 plus x. Except we're going to rewrite 1 plus x as x plus 1. If anybody says it's not the same thing, I will punch them in the face. And we're going to divide that by x cubed. Alright. So the first thing I want you to notice is the difference of degrees in the power. We have an x cubed in our divisor, and we have just an x to the power of 1 on our outside. So what I like to do, just to keep things systematic, is plus 0x squared plus 0x plus 0. I know all those just mean 0. I'm not an idiot, but it's just to keep things systematic. So it just looks better, and it helps me think. So anyway, you don't have to do that, but whatever. So the first thing that we're going to do is we're going to look at our x, our first value. So what do I have to do to x to get x cubed? Well, obviously x times x squared gives x cubed. So we put x squared on the top. Now you you times this out by all your values at the front. So x squared times x gives us x cubed, and x squared times 1 gives us x squared. Put all this in brackets and we minus it. So x cubed minus x cubed is just 0, and 0x squared minus x squared gives us minus x squared. We drop down our next value, plus 0x, and we repeat the process. So now I'm focusing on my negative x squared. So what do I have to do to x to get negative x squared? Well, I times by negative x. So we write our negative x up here, and then we repeat our process. So negative x times x gives us negative x squared, and negative x times 1 gives us negative x. Minus this from this, so minus x squared minus x squared gives us 0, and minus x gives us plus x. Drop down your last value, and you stop when the degree of the power is the same as the degree of the power at this degree of the power is less than the degree of the power at the front. So since the degrees are the same, we do this process just one more time. So what do I have to do to x to get x? Well, obviously I times it by 1, times by 1, then I repeat this process. So 1 times what? Well, 1 times x gives me x, and 1 times 1 gives me 1 minus these. So x minus x gives me 0, and minus positive 1 gives me negative 1. This value here is my remainder. Alright, so Kramer, this is proof that mine works. What we do is, the way we can rewrite x cubed over 1 plus x is whatever we had on the top. So x squared minus x plus 1, so I'll write it over here. Plus whatever our remainder is, negative 1, over whatever we're dividing by, x plus 1. Now if we rearrange all of this and sort of simplify it down, we get 1 minus x plus x squared minus 1 on 1 plus x. Therefore, right hand side equals left hand side as required. So, there you go, Kramer. My process does work for long division, and this is proof. So if you want a pension, or pension, I know you do free and I don't, and you're probably a lot better at it than I am, but I'm just trying to prove to you that it works. So, that's the process that I do it. That's the way I rewrite it, and it seems to work every single example that I do, so all is good. Thanks for watching.